Welcome to my Flash Talk. Recent years have witnessed a prominent trend in service operations. That is, more and more services are provided online in complement to the traditional in-person offerings. In this talk, I'll be using telemedicine in the healthcare setting as an example to show what are some of the behavior differences when patients are waiting online versus when they're waiting in person in order to receive the outpatient clinical service, and what are the implications to the scheduling and sequencing policy. This work stemmed out of discussions and questions that came during the pandemic when telemedicine skyrocketed. This plot is showing the share of healthcare visits that are virtual. So before the pandemic, there's very limited use of telemedicine. When pandemic hit, it substantially increased. It has mostly plateaued and stabilized at high level. There are obvious benefits of using telemedicine. In addition to its convenience, we also have a medical paper showing that telemedicine has the potential to reduce the disparities between patients coming from different socioeconomic backgrounds. However, there still remains questions as to how to operationalize this new modality. This report that came out from McKinsey demonstrates some of the remaining challenges to scale telemedicine service. I would like to draw attention to one particular challenge, which is the focus of this work. That is, how to integrate telemedicine with in-person visits to enable a hybrid service model. When talking about appointment management, there are a lot of questions that arise: patient panel size, scheduling, and sequencing. The ultimate goal of this project is to provide some guidelines to our clinical collaborators as to how they want to sequence the two modalities. What they have been doing is in a pretty ad hoc manner, in the sense that some providers dedicated a block for televisits. So all televisits happen during that specific period of time only. Some providers alternate between the two modalities. So in-person, tele, so on and so forth. Some providers will just randomly assign patients into a slot. So clearly, there's an opportunity for us to use some data-driven approach to provide some evidence-based structures as to how these important decisions should be made. In order to make that decision, again, there are a lot of factors we can consider, such as the patient punctuality behavior, the variance of the duration, etc. But for this work, we'll be focusing on service incompletion, which we believe is one of the first order issue as to how you should design the appointment system. So an incomplete visit is that an appointment was made, it's not canceled in advance, but for various reasons, it does not happen. I would like to emphasize here that an incomplete visit can be caused by two very different behaviors. The first behavior, which we refer to as no-show, is that a patient did not show up at all on the appointment day. And the second behavior, which I refer to as abandonment, is that a patient showed up on the appointment day, but for various reasons, they left without being seen. What we try to understand is that there are two different behaviors that contribute to this visit incompletion and potentially should be treated by very different interventions. How does this behavior depend on visit modality? If it does or doesn't depend on visit modality, how does that impact appointment integration? So this work lies broadly in the literature of telemedicine, patient no-show behavior, and abandonment behavior. I would like to mention here that although there's a vast literature in healthcare operations management about patient abandonment behavior, predominantly they are in the emergency department setting. As far as we know, we're one of the first to study patient abandonment behavior in the outpatient setting. So our empirical setting is the outpatient medicine clinic. We have patient visit level information. We also have a few timestamps, including the scheduled start time, the actual check-in time, and the actual checkout time. As a summary statistic, the average incomplete rate is 20% for both in-person and telemedicine patients. We wouldn't be able to disentangle these incompletions into no-show and abandonment from our data set. Now, I would like you to remember this number, 20%, because when I approach the end of the talk, I'll show some very interesting results. Our research question is the impact of provider availability on service incompletion. So what do I mean by provider availability? For focal visit, we'll be looking at a 3-hour window prior to the focal visit. And for all appointments that are scheduled to happen within this window, we will track their checkout times. So if everybody check out prior to the focal visit, we will consider the provider to be available. On the other hand, if there's another patient coming in but check out at a later time, we will consider the provider to be still under the care of other patients, thus not available for the focal visit. So this is the main treatment variable in our study. Our hypotheses are, first, provider availability decreases the risk of visiting incompletion. And second, this impact is heterogeneous across different modalities. So implicitly, you can tell from our research hypothesis that we're trying to disentangle incompletion into no-show and abandonment, because no-show behavior is less likely to be affected by provider availability. On the other hand, if the provider is not readily available, then the patient may have to wait, get frustrated, and have a lot higher chance of leaving without being seen. So if we see a significant impact of provider availability on service incompletion, that indicates there are abandonment happening there. It seems straightforward to use this probit model, where on the left-hand side, we have the dependent variable indicating if the focal visit is incomplete or not. On the right-hand side, we have the treatment variable indicating if the provider is available for the focal visit or not. We also have a rich set of control variables, including patient level information, patient visit level information, as well as provider fixed effect and clinic fixed effect. However, a direct estimation of this naive model is problematic. Indeed, we have three estimation challenges. The first estimation challenge is that there might be some unobserved factors affecting both provider availability and service incompletion. And the second estimation challenge is that, like most of the retrospective study, our data is not perfect. Indeed, we have a lot of missing checkout times. Since we infer the provider availability from previous patients' checkout, we indeed have a lot of provider availability missing. And lastly, even though provider availability is not missing, it may be errorly recorded. The idea is that the front desk staff may prioritize other duties in the middle of the day and postpone the checkout of some of the patients at a later time. In order to tackle those estimation challenges in a unified framework, we augment the naive model with a few other equations. For sake of time, I'll be only discussing how we deal with the endogeneity issue. So the main model consists of four equations. The first is same as our naive model, where we try to study the treatment effect of provider availability on service incompletion. In the second equation, we try to instrument availability with an IV, that is the number of scheduled appointments for the same provider within a 3-hour window prior to the focal visit. The idea is that if there are more visits scheduled prior to the focal visit, then the provider is more likely to run overtime, thus not available for the focal visit. On the other hand, since this is a scheduled number, not actual arrivals, this number is not likely to be correlated with the incompletion of the focal visit. Together with appropriate method to deal with missing value and measurement errors, we have a unified framework where we have some asymptotic results to provide some theoretical guarantee as to the performance of our estimator. Specifically, we show that our estimator is consistent and asymptotically normal under relatively mild conditions. I would like to mention here that the three estimation challenges have been studied individually in the literature. There has been literature that tries to tackle the three estimation challenges, two of them at the same time. To the best of our knowledge, we are one of the first to tackle all of the three estimation challenges in the unified framework. But I want to spend more time on empirical findings. Now, I will be able to answer our research question. What is the impact of provider availability on service incompletion? We show that for in-person, this impact is not significant. But for telemedicine patients, if the provider is available, it decreases the service incompletion rate by 7.4%. To facilitate better interpretation, remember this number 20%. Now I would be able to disentangle this incompletion into two parts. So for in-person visits, all the 20% incompletions come from no-show. There's no significant abandonment. But for televisits, this 20% incompletion is actually a combined effect of 18% no-show and 9% abandonment. This result is perhaps surprising at first glance to some of you, because you may imagine that if you are seeing the doctor online and the doctor is not readily available, you can do your own work, surf the internet, so probably you are more likely to stay around. However, after second thought, our results still make sense. Indeed, we have two mechanisms. The first mechanism is the sunk cost. If you travel in person to the physical location, you incur the sunk cost on time, commuting expenses, and a lot of things, versus if you are waiting online, you do not have such costs, so you are more likely to abandon. The second mechanism is the waiting formation. If you're in the clinic, you can observe what the nurses and the providers are doing, so you this which is related to operational transparency literature. Maybe you have a rough idea about the queue length. Versus if you're waiting online, you do not have such information. Now, the next question is that does it really matter? If this disentangling of the incompletion into two different behavior does not inform how you should design an appointment book, then probably you just look at the incompletions, which is very easy. Indeed, we have a comprehensive counterfactual study, and I would like to summarize the numerical findings in words. Our objective is to minimize the weighted average of abandonment cost, waiting cost, and overtime cost. And we find that the optimal sequencing rules are very different with and without taking into account the abandonment behavior. And not only they are very different, an inaccurate quantification of abandonment versus no-show can lead to highly suboptimal sequencing rules, which incurs a huge optimality gap. In summary, in this work, we show that telemedicine patients are more likely to have an incomplete appointment if the provider is not available. However, in-person patients are not sensitive to provider availability. We show that abandonment behavior impacts sequencing decisions. For my next project, I used some experiments to show what are some of the mechanisms that could explain these behavior differences when patients are waiting online versus when they're waiting in person, and what might be some of the effective interventions that could mitigate the abandonment behavior. If you're interested, the paper is available on my personal webpage. Thanks for listening.